Every day, modern healthcare facilities collect massive volumes of high-acuity patient data, routing it straight out of their buildings to distant, centralized cloud servers. The physical limitation of this design is distance. Sending a raw data stream to a cloud server and waiting for an analysis to return typically creates a 10-second round trip. In high-acuity medical environments, a 10-second delay is a structural clinical failure. When a cloud server takes 10 seconds to process a live video feed of a falling patient and return an alarm, you aren't preventing an injury. You are merely documenting it. Beyond the sheer physical lag, streaming raw, protected health information outside the hospital's physical walls introduces massive data egress liabilities and strains the limits of network bandwidth. This visualization shows the daily reality for clinical teams, a dashboard overflowing with red notifications. Remote EHR algorithms rely on static data to trigger thousands of generic, false positive warnings per shift. The human impact of this noise is a desensitized staff. Nurses are forced to sprint to rooms for high-priority fall alerts, only to find the patient is sound asleep. Hospitals do not suffer from a lack of predictive data. They suffer from a lack of immediate, physical context that a remote cloud simply cannot provide. Augusta Hitech addresses this by severing the hospital's reliance on the cloud entirely, bringing the artificial intelligence inside the physical walls via the localized Benthic ecosystem. This split-machine architecture physically separates workloads across bare metal workstations. Heavy data processing never slows down real-time patient monitoring. Machine A is the vision node, a dedicated array built exclusively to process high-throughput room cameras in under 15 milliseconds. To maintain an absolute zero-trust security architecture, the Privacy Skeletal Overlay Protocol ensures that raw optical video is instantly flushed from RAM. The system projects only an anonymous 3D wireframe, eliminating HIPAA liability at the hardware layer. This enables intent-based fall interdiction. The local vision node tracks the velocity of skeletal joints to detect the kinematic intent of a fall, a full 2 seconds before the patient hits the floor. That 2-second predictive buffer allows the local system to instantly trigger an autonomous in-room audio intervention. It de-escalates the patient before a human responder could even reach the door. By eliminating wide-area network latency, healthcare operations shift from reactive post-event auditing to proactive closed-loop interdiction. The secondary hardware array is Machine B, the Necton reasoning node. This is built to absorb massive spikes in natural language processing and EHR data crunching. Utilizing local large language models, this node can instantly summarize a 50-page patient chart or generate shift handoffs without ever touching the public internet. This architecture creates fused awareness. The system acts as an event-driven listener, cross-referencing incoming administrative EHR alerts with the physical reality captured by the vision node. For example, if the EHR generates a critical fall risk alert, but the vision node confirms the patient is in a deep, motionless sleep, the system intercepts the signal. The audible floor alarm is suppressed entirely, protecting the nursing staff from cognitive noise. However, if that patient awakens and exhibits neurobehavioral agitation, the streams fuse instantly. The system elevates the warning to priority critical before traditional vital monitors even register a change. This localized intelligence extends to equipment through visual DNA. The node maps the geometric signature of medical hardware and can lock physical perimeter doors in sub-200 milliseconds if it detects unauthorized movement. The local edge mesh functions as an intelligent contextual filter, separating administrative theory from clinical reality. On a macro scale, a fully deployed facility operating on this localized mesh provides omnipresent predictive intelligence, while ensuring zero PHI data ever leaves the building. This shift transitions healthcare software from an open-ended cloud subscription expense into a predictable, capitalized hardware asset. The financial recovery is direct. Mitigating 10 falls annually saves $350,000 in risk recovery, while tagless perimeter lockdowns retain an average of $150,000 in mobile assets. Combined with initial procurement costs, the system delivers a full payback in 10 months. Automating chart summaries and eliminating equipment search workflows returns over 6,500 hours of labor to the floor. Across a 150-bed layout, that is the productivity equivalent of 3 full-time nursing roles reclaimed, without additional hiring. True patient safety and data sovereignty cannot be achieved in a distant data center. They demand artificial intelligence that operates securely at the absolute edge of care.